Secant squared x minus 2 secant x equals 0. We're going to solve for x. So the variable is x, not theta here, which is also why it's written this way. It's still one revolution, so our solution, our answers are going to be between 0 and 2 pi. So if you're having trouble kind of visualizing how to factor this, you can also, picture this as x squared minus x equals 0. If you're going to keep that in your work, you want to do a let statement or do it on scrap paper. But hopefully you can kind of practice a bit with the trig ratio. So normally I factor out an x. In this case, I'm going to factor out a secant x now. Okay, so then I'm going to have secant x equals 0. And here I'm going to move the 2 over. Secant x equals 2. All right, so now I'm going to write the reciprocals. So cos x would equal to 1 over 0. And cos x would equal to 1 over 2. So in this case, you can't have 0 in the denominator. We can say it is undefined. You don't actually have to write out that it's undefined, but therefore my answer is no solution. You do need to write out the no solution part, as that is part of your answer. All right, now we're going to look at this one. You should recognize that from your triangle. So I actually have a triangle drawn here. So 1/2 would be adjacent to pi by 3. So your reference angle is pi by 3. And make sure you don't call it theta r now, you call it xr. I know that's where I catch myself often writing theta still. And then we're going to look at the quadrants. Well, according to our cast rule, cos is positive at 1 and 4. So in quadrant 1, theta equals theta r. Make sure you write, oh, see, I did it there. I wrote at theta instead of x. That is a habit that I shouldn't say we, I have. X equals pi by 3. And in quadrant 4, we want to picture, and again, I like to picture, it's quadrant 4 is close here. So that would be 6 pi by 3, which is 2 pi. So 1 less would be 5 pi by 3. And again, it's just one revolution, so those are my values of x.